Variations on a rectangle. This is really, yeah, it's really 5-4F. 5-4F. Variations on a rectangle. So we're going to take a rectangle. Did I already give you guys that worksheet that you're going to do for the weekend? Okay, good. Except for Jihan. This is your homework. 4 problems.
Did you mean to cross that out or underline it?
Underline it.
Wait, do I have one too? She handed out yesterday. I know, I can't find it.
Okay, it says, shh. All right, now we've maximized the area of a rectangle, but we're going to do a variation on a rectangle. So what happens here is one side of a rectangle is replaced by a semicircle. So, for example, here's your rectangle. And instead of this side being straight across, it's being replaced by a semicircle. So it's nice to just draw that in. Okay? So our shape now is this rectangle with this semicircle on it. Making a convex. Okay, on your worksheet there's one that's concave. It dips into it. This is convex. Okay. What is the maximum area given that the perimeter is 500 feet? So let's go ahead. We're going to set up 2 equations. We're going to set up an area and a perimeter. So let's label this side down here X and this side Y.
Like all the way to the top is Y? Or?
Yeah, no. So to here, I'll put it in red. This is Y, and this is X. And I'll tell you how we're going to deal with the rest of it. So if we're going to find the area of this shape, we're going to find the area of the circle, the area of the rectangle, and then the area of the semicircle. Okay? So let's find the area of the rectangle. That's pretty easy. The area of the rectangle is X by Y, X times Y. Plus, now let's find the area of the semicircle. Well, the semicircle is going to be 1/2 pi r squared. And almost. It's not X. X is the diameter.
I mean, half X.
Yes, very good. We don't want to put another variable in. We don't want r. Okay, the radius of this semicircle is 1/2 X. The radius is 1/2 X. We don't want to add more variables to this. So we're going to do 1/2 pi r squared. 1/2 X squared. All right, so let's fix this up a little bit. Area equals xy plus, you have to square the 1/2 and the x, so you get 1/4 times 1/2, so you get 1/8 pi x squared. Did I lose anybody out in the mathematics?
For the fraction, do you just technically just multiply the denominator by 2?
You're multiplying, yeah, you square 1, which is 1, you square 2, which is 4. And then you multiply 1/4 times 1/2. All right, that's our area. So let's leave that for a minute. Now let's set up our perimeter. Okay, our perimeter is going to be 500 equals, and we're going to add our way all the way around this thing. Not across this yellow part, okay? The perimeter is just the outside. So we need an X, we need 2 Y's. Picture yourself walking around this thing. And now we're going to need, yeah, we're going to need half of the circumference. So 1/2 2 pi r, and r is 1/2 x.
Is 2 pi r in parentheses?
It doesn't matter. I'm going to multiply all that together anyways. So it's half the circumference of the circle. 1/2 2 pi r, and r is 1/2 x. So let's fix this up a little bit. So 500 equals x plus 2y, and then all of this is going to be 1/2 pi x. Or you can say pi over 2x if you wanted to. Or 1/2 pi x. It doesn't matter. Either way. Okay. So we need to maximize the area. We're going to take the derivative of our area function, but right now area is in terms of x and y. So we're going to go to our perimeter, and let's solve for y here, and then plug it back in. Pretty bad, huh? Okay, so let's subtract these guys over to the other side. So we get 2y equals 500 minus x minus, I'm going to rewrite this as pi over 2x. And then I'm going to divide everybody by 2. So y equals 250 minus 1/2 x minus pi over 4x. So far so good? Okay. So let's take this y equals, and we're going to go up here to our area and we're going to plug it in. So now area equals x times 250 minus 1/2 x minus pi over 4x plus 1/8 pi x squared. It does, huh? It's a really good problem is what you said. Good. All right, so area equals, yeah, it's whenever a circles and triangles. All right, 250x minus 1/2 x squared minus pi over 4x squared plus 1/8 pi x squared. Really bad, huh? Okay. You can combine stuff, but you know what? I always think that's like, people don't like it because they're all different fractions. Let's just take the derivative. You won't need to do all that. All right, so let's take the derivative of the area function. So you get 250 minus x, bring the 2 down, minus pi over 2x, and then bring the 2 down. So this would be plus pi over 4x. And it's really not that bad. I mean, it's not a quadratic. It's actually a linear, to solve. We're going to set this equal to 0 and solve it. So let me show you how you solve this because you have a lot of different x's here. So here's what you want to do. 250. Let's bring all the x's. So we're setting this equal to 0. Sorry. Let's bring all the x's over to the other side. Okay? So I'm going to add this x over. I'm going to add the pi over 2x. And I'm going to subtract the pi over 4x. And in order to solve this, I need one x. I've got 3 of them. I need to combine them all together. You can factor an x to the front. Okay? So you get 250 equals x times 1 plus pi over 2 minus pi over 4. That's just a constant. I could have combined those all together. I just didn't want to deal with the fractions and stuff. And then your last step finally would be to divide by that whole thing.
I would have just
Combine them? Yeah, like you can do that. You can get a decimal answer. Or you can combine them using the common denominator, stuff like that. I've done it both. I've done it either way. It just depends on what I'm feeling like. Okay, so that reduces, and x equals, and then you get your trusty calculator out. As long as nobody's stolen it. 250 divided by, someone stole someone's calculator earlier today. I know, you can't trust anyone.
These calculators are expensive.
That's true. It was my fault. I told her to put it right there on the ledge, though. I just admitted fault on camera. Dang. Okay, x equals camera. X is about 140.0. Wow.
20.0.
Yeah.
Well, 0.024788. It's about 140. Okay, so it says, what is the maximum area? What are the dimensions? So now we got to go back, figure out what all this stuff is. All right, so here's y. Y is 250. So if you have x on your calculator, okay, do 250 minus 1/2 times your answer minus pi over 4 times your answer. And y is, guess what y is? It's half as much. That's so fun. Okay, so let's go back up to here.
So X is actually bigger than that?
Yeah,
Or drawing is off?
drawing is way off. So X is 140, Y is 70, and these are feet. And then the area would be, and you can go to any of your area formulas. Don't go to, you know, A prime. You need to go to an area formula. I'd probably go to this top area formula, X times Y. So I'd go 140 times 70 plus 1/8 times pi times 140 squared. You get 17,496.9 square feet. It's a lot of area. There you go. Area? I went to this. Oh, okay. I went to the area equation right here, and I plugged in X is 140 and Y is 70. And just figured it out. There you go.